notice that we have pi in there, which means that this might be a little more interesting in how the numbers work out. So let's start, before we graph anything out, let's just try and establish a little bit about this. If we were to rewrite this, we could say 2 tan. We do notice that the pi in both cases, so we could pull pi out. Pi x plus and then 1/2. Pi times 1/2 would give us pi over 2. Check. Yeah. All right. So let's see what that tells us. So period of a typical tan function is pi. And so then what we do is we just divide by the number in front, which in this case, the number in front is pi, which might be a bit weird, but that works out kind of nicely. It just comes out as 1. And then we recognize that we also have a shift in here. So we could say the shift is equal to, and it's positive, so it would be a negative shift to the left, and we can indicate that with a negative there. So if we were to sketch this out, we might say, okay, if the period is 1, then we don't have to include any pi's on our graph here, which is kind of interesting. And if the period is 1 and we're not looking at the shift at all, therefore if we're not looking at the shift, we know that it goes through 0, and a period of 1 means it should go to 1/2, to negative 1/2, and in between that would be the 1. So that would draw out nicely, and we can draw asymptotes there. And so 1, 1.5, and we can mark this as 2, and so on. Now, what we would want to do there is we've got a layout of this, and our asymptotes are clear, so domain and range easy from here, but we have to get the shift in place. And so, so what we want to do is we want to say that everything's shifting to the left by 1. So I'm going to just shift everything over. And we would say this becomes, instead of 0, it becomes negative 1/2. And so here's what it will look like now. So we can cross this out, and we can say that everything has shifted over by that half. And so this would be 1. And so on. So basically, we can see that our asymptotes are now negative 1, 0 right on the axes, and positive 1. And then, of course, if we were to say this is 1.5, then we'd have 2, and we'd have the same thing going on. So it would have an asymptote at 2 as well. So now we can kind of visualize what's going on here. So let's get going. Range, y, any real number. Okay, so we remember that with the tan ratio, they go up forever, they go down forever. The 2 in front, does it make them more rapidly go up and more rapidly go down? Yeah, but they still cover all real numbers, so it stays the same. The domain, x is all real numbers except, we'll put a comma there, except x cannot equal, so let's take a look at this. We'll pick a starting point. We know that there's an asymptote at 0, and then we know that the period is 1, so we could say plus or minus 1n, because it could, the asymptote would happen at 1, it would happen at 2, it would happen at 3, it would happen at minus 1, it would happen at minus 2. So we've got that covered. I do want to point out that this is a right answer, but it would probably be more commonly written as 0. Well, we don't need that 0 there at all. And 1 times anything is just itself, so we could just write it as plus or minus n and be done with it. And there we go.